When and why does it make sense to move from spin coating to slot die coating? Hi, my name is Roar and I would like to give a quick introduction to how and when slot die coating can be an advantage compared to the more commonly used spin coating technique. Spin coating is typically the starting point for many different coating technologies, and for very good reason. It's simple and great for early stage experiments. It's possible to prepare uniform films quickly with relatively little preparation, and it's been a workhorse in the labs for decades. But there are especially two scenarios where shifting from spin coating to slot die coating can be an advantage. The first is if the coating materials are either very expensive or difficult to get in abundance, or second, when the research has reached the stage where the prospects of upscaling comes to mind. Spin coating is fundamentally a batch process and is typically aimed at processing small substrates one at a time. In the process, there is typically a huge material waste, and reproducibility between operators and labs can at times be difficult, as even small differences in how the ink is deposited can lead to differences in the final film. As the film formation, when using spin coating, relies on a delicate combination of centrifugal forces, like the spinning speed, the spinning time, ink viscosity, surface energies of both substrate and ink, it can sometimes be very hard to scale up an already established process to larger substrates. Slot die coating, on the other hand, is a pre-meter technique, where the wet layer thickness is a direct consequence of 1. The coating width, 2. The coating speed, and 3. The pumping speed. Opposed to spin coating, slot die coating has no material waste, and the wet layer thickness is known beforehand, given by the aforementioned coating parameters, even for new materials. This makes the techniques extremely useful for research using non-abundant or expensive materials. The real advantage of slot die coating, though, lies in its scalability. Since the coating principle is the same for a small lab-scale slot die coater and a huge industrial setup, the transfer to larger scale, both in terms of size of the film and the production volume, is tremendously facilitated compared to spin coating. Not to say that everything is just a one-to-one transfer. Drying is, for example, not always carried out in the same way. But what is achievable on a small lab-scale coater can typically also be achieved on larger systems, given a few adjustments. Slot die coating is also inherently compatible with roll-to-roll processing, which is the backbone of many large-scale manufacturing lines, and this allows for continuous coating, inline drying and integration with additional steps like curing or surface treatment, all while keeping the process moving. I would here like to emphasize that this doesn't mean that spin coating is bad. It's still an excellent tool for early research material screening and proof of concept work. But once uniformity, reproducibility, material usage and scale starts to matter, the gap between spin coating and industrial reality becomes very clear. So upgrading from spin coating to slot die coating is often less about replacing a tool and more about aligning a process with future goals. If these include scale-up, pilot production or manufacturing relevance, slot die coating could provide a much smoother path forward. For further information about coating methods, scalability and how lab processes translate to industry, feel free to explore our other educational resources and blog posts. Thank you for watching.